Okay, let's talk about polynomials in factored form here. Okay, before we do that, let's do a little review. Right? Let's find some x-intercepts. So I have a function in this form, right? So these are factors. It's all multiplication. I want to find the x-intercepts. Well, what are x-intercepts? X-intercepts are um, places where the graph crosses the x-axis, and that's when y is 0. Well, since f of x is y, all I have to do is set f of x equal to 0. So we need to solve this equation. Well, this is like any factored equation we've ever solved, right? We've done hundreds of them by now, right? We just set each factor now equal to 0 because it's all multiplication. So if I set x minus 2 equal to 0, then this whole thing will be 0 if x equals 2, right? You can plug in 2 and you'll see that's true. Well, when x is 2, when y is 0, that's the x-intercept, 2 comma 0. Right? Now let's do x plus 1 equals 0. So when x plus 1 equals 0, subtract over 1, x equals negative 1. Again, you can plug it into here and show that it's true. It's when that'll make the y 0. Well, when x is negative 1 and y is 0, negative 1 comma 0 is the other x-intercept. Right? So we have two x-intercepts. Okay, how about y-intercepts? Well, y-intercepts are when x is 0. Right? They cross the x or the y-axis. So x is 0 on the y-axis. So we really just need to plug in 0 for all these x's. So what are we doing? We're actually evaluating this function at x equals 0. Okay, keep in mind, we're not solving, we're evaluating. We're plugging in a number, we're going to get a number. That's evaluating. Well, pretty nice. All the x's are 0, then all these terms are 0, and we're left with this term right here. So it turns out that when we're looking for y-intercepts, right? So when x is 0, y is negative 3, it's the exact same thing as the constant. So that's why we've been talking about the constant term. So if you see the constant term or can figure out the constant term, that's the y-intercept. All right? Okay. So you want to stop the classwork or the video and do classwork problems 1 and 2. All right, let's talk about sketching graphs here. So what I do is sketch a possible. When I say a possible, there could be, we're not going to do this exact, and there could be many different versions, right? And then, so we just want one possible graph of this. Here we go. We have a nice polynomial in factored form. And we've already discussed we can multiply the largest powers in each piece to find the leading coefficient of the degree. We can multiply the constants together to find the constant. All that stuff will be great. Okay, so if we want to graph this, well, what do we need? We need the x-intercepts. Well, we learned that the x-intercepts are simply solving each one of these when we set them equal to 0, which is just the opposite sign. Right? So if I said x minus 3 equals 0, add over 3, x equals 3 is the x-intercept. Likewise, negative 1 will be the x-intercept because I'll subtract 1 from both sides. Negative 4 will be the x-intercept because I'll subtract 4 from both sides. All right, so those are my x-intercepts. Well, the y-intercept is the constant, right? So how do we find the constant? Remember, we don't have to multiply them together. We just multiply all the constants together. So negative 3, 1, 4. Negative 12 is the constant if I were to multiply this all out. So 0, negative 12, that's the y-intercept. Right, now I need a degree, and I need the degree and the leading coefficient for the end behavior. Right? So how do I find the degree? We'll take all the largest power terms in each parenthesis and multiply them together. So it turns out it's just x times x times x. Oh, this should not be a 2. Right? This would just be an x cubed. Let's just change that real fast. Okay, so we should have an x cubed, and then what's the degree? 3. Right? So I know that this is a squiggle. Right? It's going to be a little more advanced than a squiggle, but that's the deal. So I know the leading coefficient on this term is 1. Right? So I know it's for end behavior as x goes to negative infinity, as x goes to the left, y goes to negative infinity, y points down. And as x goes to positive infinity, x goes to the right, y points up, so y goes to infinity. Right? So I know left down, right up. Right? So that's a lot of information right there. So I have x-intercepts, I have y-intercepts, and I have end behavior. Well, let's plot them all out. All right, my nice coordinate system. Let's do all my x-intercepts. All right, so this dot's a little off. It should be on negative 4 here. All right, now let's do my y-intercept at negative 12. Let's do my end behavior. So as I go to the left, I know I have to point down. So I'm just going to make a little note to myself. However I end, I need to point down this way. As I go to the right, I need to point up. So I'll end in that direction. Okay, and then one final thing when you do polynomials. they're going to have these maxes and mins, right? Well, maxes and mins occur right in the middle of these points. So I'm going to have a max somewhere, or a min or a max, either one, in the middle of these 2 points. I'm also going to have a maximum in the middle of these 2 points. All right, so now I have to end going up, so I have to have, it has to come down, have a max somewhere here, cross this point, cross this point. Oh, I said max, I meant min. Cross this point, have a max somewhere here, cross this point, and follow through. All right, and here's where it's possible. The maxes and mins, I'm not sure where they are. I'm just going to kind of estimate. All right, so this to me is a possible graph of this polynomial. And look, it crosses the x-axis where I want it to, crosses the y-axis where I want it to. It ends the way I want it to, right? Left down, right up. The maxes and mins are in between the points. I'm good. All right, that's my best estimate of what this graph would look like. And you can see it's kind of like a cube. It's our squiggle, except there's just more pronounced in the middle. But yeah, all right. Well, let's check it out. This is the real graph, and here's my graph. You know, my max here is a little off. My min down here is a little off, but general shape looks pretty good. Right? I'm pretty happy. Okay, so let's complete class for problem number 3. Okay, so now let's do this. So polynomials in factored form can be written as this, what we just have seen, right? It's x minus the factor, or x minus the actual x-intercept, x minus the other x-intercept, and just list them out. And then there's this constant out front, right, that'll get the peaks and the valleys, the maxes and mins correct. All right, so here's our general form for factored, and all this is where a is a constant, which just means it's going to be a number. Right? We know that the x minus r's, these pieces right here, these are factors. Right? How do I know they're factors? It's all multiplication. I know that the actual r itself, change the sign, this r, that is the x-intercept. And I know that however many of these I have, then that's going to be my degree. Okay. All right. Okay, so let's try this. So I'm going to write the equation of this graph. Well, what do I need? I need x-intercepts. Let's find those. So it looks like -1. These go by 2. So -1, 2, and 6. Those are the x-intercepts, -1, 2, and 6. Okay, make a note, and this is very important, multiplicity here. Whenever you see a vertex as one of the x-intercepts, that means that had to have come from multiple x-intercepts. It means there's more than one of them here. All right, so make a note. That's huge. It's a wonderful key concept. Anytime you see a vertex on the actual as an x-intercept, it means that particular x-intercept occurred more than once. All right? Okay, so I know the x-intercepts. Well, the y-intercept is labeled 0, -12. That's nice. So let's write it out. Our factored form is some constant times, and we change the sign of all of these. So x plus 1, a 2 becomes an x minus 2, and a 6 becomes an x minus 6. And then I knew that this one was going to happen more than once, and the least degree I can do that to is a 2. All right, so it's any power, even power, but that's why in the directions, if you look back, it says least degree, because they could be higher degrees, but this is the smallest one that would occur. All right, and again, how did I know that? Because the vertex is right here on the x-axis. It's one of the x-intercepts. All right, now my job is to find this a. Well, I can do that because I know the y-intercept. And it's easiest because I plug in 0 for all the x's. So I plug in a -12 for the y and a 0 for all the x's. So 0 plus 1 is 1, 0 minus 2 is -2, 0 minus 6 is -6. And then I just have to solve this equation, right? And this one is solving because I'm actually getting a variable equal to a number. So I get a -24, a times a equals -12, divide over -24, and a will be a half. All right, so now I actually know what this constant is. Right, and I'm going to write a as a half as 0.5 just because when I write a half, it looks weird when I write it in this way, right, without an equation editor. So it's 1/2, and then just times all my factors, x plus 1, x minus 2 squared, because again, the vertex at the x-axis, and then x minus 6. All right, that's it. So x-intercepts, y-intercepts to find your a, and then you're good. All right, that's actually the end of the video, so stop this and do class work problem number 4.